First thing that we have to know, what is RANSAC and what is the full form of RANSAC. That's thing we have to know first. So let's see what is the meaning, what is the full form of RANSAC. Then we have discussed going to how these things are actually applicable for a productionization based model. Actually, in this video, we are going to discuss if in our data set there have huge amount of outliers, then how to build in such situations, how we build such models that can handle these things. So let's see step by step. So the RANSAC, the name from the name RANSAC, the full name is RANSAC, it's a random sampling consensus. So its full form is random sampling consensus. Okay, this RAN is come from RAN. This RAN is A. This is A. This is A. Is come from this is A. And C. This C is responsible for this C. Okay, this is the because of these reasons we call this method is a RANSAC method. Okay, this is random sampling consensus. Okay, so now the first thing that we will have to apply the RANSAC on the model that have the huge amount of outliers. Okay, now the first questions that we have, we want the answer, can we build such a robust model in the presence of outlier? Can we build a robust model in the presence of outlier? Can we build such model? Okay, let's see it. Suppose it will be better if we just try to understand this thing through picture. Suppose let this is in this set we have some data set like that. Suppose let these are the maximum data sets are look like this one. This one maximum data points, and they have some outliers onto it. Since there have huge amount of outliers in this, in that side also there have some outliers. Just if you think in a logically, so our perfect model will be look like on that line, that if you make some regression model on this data in natural human way, if you think the perfect model will be look like in that in this type. But if we use the linear model or some kind of technique on this data set, so since in this data set we have a huge amount of outliers, because of these reasons our model will get affected. So suppose let's take this model that we call is called the L star. So since we have huge amount of outliers, so this model is affected. Now let's after getting the affected, we got another type. It will be better if we did another. Wait. After getting affected, we got another kind of line, this one. Since in this side, in that side, we have a huge amount of outliers. So this regression line will be affected on this outlier and it will be moved on that side. So suppose let's take, we will got this is an L1 and it is an L star. Okay. Now how we will find what will be the error? Suppose let's the data model that we have built, we have the data sets like that. Suppose let on that data, detrained data, we have built this model. Detrained data. Detrained data is actually look like this type. Xi, Yi. Onto this data, using these data are actually distributed in this manner, and on this data set we have built our model L1. We have built our model L1. Here it will be better if you Xi is equals to R, and as well Yi also belongs to R. This regression model, it is affected by the outliers, but we want to get the best fitting model L star like that. So how we will doing these things? That's the questions I'm asking here. How will do is how will build such kind of robust model? Here robust model is here simple L star. L star is here robust model. How you will build this type of? How we will build it? Let's see it. So just I'm just going to discuss this. I'm just simple. I'm taking here some linear regressions. It will be better for. Suppose let's on this detrained data set we are going to build some use some linear regressions onto it. We have used some linear regressions on this data set, and we will build some model. Let this model is called the L1 that we will build, that we have built here, L1 models. Okay, and it's we have seen, just see this L1 model is not a robust model. It's simple, not a robust model. Okay, it's simple. So now how we'll find why these things are is not robust or not? Simple. If you just remember the linear regressions, what I am doing in linear regressions, if you remember, is the linear regressions is simple, nothing. It is we have to minimize the square loss. Okay, just if you remember. If you forget, I strongly recommend you please go to this linear regression series, then you will find the answer. In the we have to find the normal vector W, and we have to minimize this in log loss value, log square loss value. I is equals to 1 to n yi is the original output minus yi hat, it is the predicted output, and here we have to find the w, and this is the simple optimization problem that we have to do. And here y is hat, this is the predicted value, this y hat at simple the w transpose xi. That's the simple thing we have already known, we have already seen in the linear regression chapter. Okay, I think you will got the point, you will understand the point of what is actually our problem and what we are going to do. So here actually these things here, in this side we have xi, in this side we have y. This kind of model we are going to, that will be the robust, means L star type of models we are want to get, but our data sets gives up the out models like L1. Okay, that's the main problem here. How will solve this? Let's see. Let's try to understand these RANSAC problems through step by step. RANSAC. It's a very famous statistical method. First thing, it is the very famous statistical method. Mostly it is even in the computer visions, means computer visions is a chapter in the computer science. It is mostly used in the image processing and intersections of the machine learning. Okay, this is the computer vision, and mostly computer visions area the RANSAC techniques are in generally are used, typically are used. Okay, now let's see how we will just solve this problem. Let's see it step by step. First step that we have to do, we have a data set G-train. We have the data sets D-train like that. In the RANSAC, we have the data sets D-train. On this data set, in these data sets we have, on this data set we have to build such models L star that we want to get. First, on this data set we have to extract the data D0. We have to extract the data D0 from these data sets D train. How will extract it? Simply we have taken the random sampling. We have used the random sample onto it on the D train data. We have used the random sampling. Suppose let we have taken here the 50% random sample data from the data D train. Suppose let we have taken here a 50% random sample. Okay. Now in after taking this random sample on this D naught, we have to build another type of data set. We have to build a model on this data set. We have to build a model on this data set. Model. Suppose let we have in these examples, we have taken the linear model. We have linear regressions. We have built. Okay, on this data set, we have built the linear regressions and call these models. Let's call this is an L0 model. First step we have to do means first step on our training data sets, we have to extract randomly sampled 50% data, and on this data we have to build some models and call it L0. That's the simple step we have to do in first step. Now in second stage, we have to compute the outliers. We have to compute the outliers on this D-train data using these models L0. Now on the second stage, we have to compute the outliers on the D-train data. On D-train data based on the model L0. Based on the model L0. Okay, that's the thing that we have to. Let's try to understand this thing through a picture. Sorry for that. Okay, suppose let's here it is our xi. Suppose in this side we have xi, in this side we have yi, and here is our data sets. After taking the 50% means I am drawing these pictures on the D naught. Just okay, it will be better if we use the first D train data, then you will try to understand on the D. Okay, so just see this color first. It's light pink color type. This is our original data set. Look like here huge amount of our outliers in that site. Outliers. Here also we have outliers. These are the data sets, original data sets. D-train data sets means I am using color D-train here. Now I am using here this orange type color, this color, orange color. I am using this orange color that will be lie on our D naught. Means I am taking here randomly sample 50%. So suppose let's this one, 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 and also 50% means the outliers also not affected like that. Like only these few points are come onto our D naught. On this D naught, these built L or not models we have built. So the most of the outliers is not on our L naught, is not affected by L naught, since we have randomly sampled this data. Okay, now after building this, we have to calculate it this on these models. L0 model that we have built. L0 means I am using here this slide. Means the L0 will be like that. Means there have not so much outliers on the data set D0. So the L0 will also be not affected so much. Suppose let L0 model, it's look like this. This is an L0 model. Okay. Since in D0 we have not so much outliers, so D0 is not in maximum position lie on here and some of the outliers here. So suppose look like this type of L0. Now we have to calculate it, this value here. Based on this, we have to calculate it. This value means this value of yi minus yi hat. Yi hat. So the yi hat here, that's value are is coming from the model L1. This y hat is coming from the value. This yi hat value is the predicted value for the L0 on the data sets D train, and this value is the actual value from the data set D train. I think you got the one. This L0 model is built with the help of the data D0, but this error value is calculated using on this data D train. That's the simple thing that we have. Okay. Now after computing this, we have to compute this value, this error value, yi minus yi hat. What for this thing? This thing is for high. This high value we have to compute. This high value means, suppose this is our this, just take this one, just take this value, these things on this value. What will be the predicted value? Y hat is here. And what is the original here? Original value will be, suppose let's the original value somewhere like here. So these will be the differences. These differences. Okay. Similarly here, if you consider the value here, suppose let's here, this predicted value is here or original value is here. This is the differences. This is the difference. Also similarly, if you take the D train data here, predicted data will be somewhere here and original will be somewhere. This kind of error look like we got. Means I am talking about, just you think yourself. This kind of error we have to, means for high value, for high, this value will be so high. This value, this yi we have to consider. Okay. And for this high error, we have taken this point as an outlier O not outlier point. These points are we call the outliers. Means on this stage, these are the outliers. Okay, that's the thing that we have to find. And after finding this outlier, we have to build another data sets D1 train. We have to build another set data sets D1 train. That data set we have to build by simple subtract the data. They extract the remove the data from this data. We have to remove this data. These outlier points we have to remove from our D train data. This, just see this light pink color. These are the whole data sets. Now based on this model L0, we have detected some outliers. Now from the D train data, we will remove that outliers point, and we have build another data that we call D1 train. That in the stage, in the second step, we have to do this job. Okay, I think you will got the point. After doing this in third stage, after doing this in start stage, using this data point, same things also we have repeated on this data set. Same things means, first on this data set, we have to randomly sample the data. And we will build the data D1. This is the random sampled. Suppose let's see the randomly say 50% random sample we have taken. D1, we have built the D1, and on this data we have made some models. L1, we have made some model L1, and on these data sets also using this formula simple, using this high yi minus yi no hat. On this data d1 train, we have find the outliers. We have found the outliers O1. These are the outliers. Outliers of these models means outliers on the outliers on the model L1 based on the data sets D1 train. Dow outlier on L1 based on the data D1 train. Okay, that's the thing, that outlier we have to find, okay, in the data. Now after finding these things, again we have to construct the again data sets in the fourth stage. We have to D2 train, and this D2 train we have to build D1 train minus, we have to remove this point. Again we have to build this data. Again we have to bring the same thing, build this data. Again we have doing the same job repeatedly. On this data D train, on this data we will use the random sampling. We will use the random sampling. On this random sampling, again we will find some data D1. Here we will find the D1. Here we will find on this data D2. Again using this data we have built the model L2. Again by sample using the high A. Here it will be the high. Here it will be the high yi minus yi hat. Using the high yi minus yi hat, we have found the outlier O2, and again this outlier, similarly this outlier will be based on the model L2 in the data D2. Same things also. Again we have built, again from these things we build the D3 train. D3 train will be simply D2 train minus O2, and again the same things also we have to repeatedly doing the same thing. Okay, I think you will got the idea how to up to when we have to repeat the same things until we have not converged. Repeat the same thing until converge. Until we have not converged. Okay, so how to, now the question is, what is convergence here? How will find the convergence? What is convergence here? So suppose let's after some stage, after some L stage, let after ith stage, let after ith stage, we got some point. Iterations, it will be better language. After ith iterations, after ith iterations we got point Li, and at the I plus 1 iterations we got the models Li plus 1. Okay, these two models we got after ith iterations, we got it. Now we have to find the cosine distance between these two models. Since we have taken in these examples, we have taken here the linear regressions. So suppose it's the L1, it's the Li, sorry, and it is the li plus 1. If these two are converged in its distance, its cosine distances will be small, hence it's the wi plus 1s. This is wi's. So these cosine distances will be small if li and li plus 1 are converged. Then the cosine distance between them are very small. So it's based on our requirement, how much error we want to remove, how much outliers we want to remove. Okay, that's the thing that we have to. It's depend on the problem to problem, latency to latency. It's depend on the situation to situation. So that's the simple thing that we have to make. So after some step, if we find, suppose let this cosine distance is very small at ith iterations, then after finding this, now we have to stop our iterations on this I plus 1 stage, and on the I plus 1 stage we reached up this point. We reached up this I plus 1 models are actually built from the data di plus 1, and this di plus 1, it's randomly sampled from this data d train I plus 1, d train I plus 1. On this data we have to randomly sampled it and we build these models. Now we have to take this data and we have to build our final models. Okay, now we have to take this data di plus 1 train. I think it is okay. Yeah, I think I'm doing some mistakes here. Actually, I am using this type of indexing to denoted these notations. So it's my bad. Sorry for that. So here in the train I plus 1. Here it will be d train. On this d train I plus 1 data sets. On these data sets, we have to build our final model L star. This is our final models, and these models are actually called the robust model. Robust models. Okay, just if you think on these data sets, practically on these data sets, we have already removed all kind of outliers. If using this simple technique, repeated technique, iterative technique, we have removed all this kind of outliers by simple these things, and only this actual data we have light on the after final these things. Okay, so on these data sets di plus 1 already we removed all the outliers. Okay, that's the simple thing we have to do in. I think from these discussions you got the idea how this RANSAC means random sampling consensus algorithm are work. So it's if in our data sets we have a huge amount of outliers, this technique is actually useful to build a robust models on this data set. And I think you got the point what is actually robust models from these discussions. Okay, so just repeat it, just recap these things. First step that we have to do, we have to take the random samples from our original training data sets, and on these random samples we have to build a models. Okay, after building these models, on the basis of these models we have to find the error value for our whole training data. And for the high error value, we have to take these points as outliers, and we have to remove that points from our original training data, and we have to build a new training data. Okay, now again we have to take in the random samples from that new data, and again we have to build the models, again we have to find the outlier from that models, and again we have to remove that outlier on our data. Again we have to doing this, the same job, that same thing we have to repeatedly doing until when we have not converged. Converge means we have when we have seen that, just here in these examples we have taken the linear regressions. If you seen that the regressor line distance between these two regression line means cosine distance between these two regression line very small, we have stop it. And on these data sets, final data sets, we have built our final robust models, not from this di plus 1. This is the sample data. We have not used this random sample data, we have used this data, training data, di plus 1 training data, and on this data set we have to build this robust model. That's the thing, that's the simple thing we have to use. When we discuss the case study, then we will see directly how these ranks and techniques are actually used to build a very good productionization. We'll see it in when we discuss the various real world case study.